Hi there, welcome back. The last time you left class, we were practicing graphing quadratic functions using tables of values. And then we talked about two different forms of quadratic functions, and we talked about the standard form of an equation and the vertex form of an equation. And we're going to be studying both of those forms in a lot of detail in Chapter 2. But the purpose of this video is to, one, make sure that you can plug in any values of x and get the correct value of y. We know that gets a little bit tricky. So we're going to do two problems, and I would like you to graph and write these problems in your notes and bring them to class next week. So you ready? Okay. The first problem that we are going to graph is y equals negative x squared plus 4x minus 2. And this is a parabola that is in standard form. So I'm just going to write that down. I'm going to box this. This is our main function to graph. And that is a quadratic function in standard form. And we'll talk about standard form a lot next week, but basically it's the highest degree of x listed first and decreasing in degree all the way till we get to a constant. So we know that this gets a little bit tricky, and I'm just going to plug in some values of x. Let's say x and y. And I'm just going to look at when x equals negative 2. So I'm going to write this down. This is what we do in calculus when we say x equals negative 2, and I'm just going to see what happens at that point. Y equals a negative 2 squared plus 4 times a negative 2 minus 2. So we know a negative 2 squared is a positive 4, but that negative is still hanging out there. So don't make that mistake. Even though you square a negative 2 to get a positive 4, you got to carry down that negative that's still in the problem. And we have 4 times a negative 2 is negative 8. And then we have another minus 2. So this is getting to be a pretty large number. And actually, if you do negative 4 minus 8 minus 2, that equals negative 14. So when x is negative 2, y is negative 14. Now I say, okay, if I'm going to use this axis, that's x is negative 2, and y is way on down here somewhere. So let's not worry about that point for right now. But let's just see what happens. We're just moving along. Let's do when x is negative 1. So I'm going to come over here, x equals negative 1, and just put a line there. And I can plug it in. Negative y equals negative 1 squared plus 4 times negative 1 minus 2. And that's going to get me a negative 1 squared is a positive 1. However, this negative remains. Negative 1 minus 4 minus 2. And we've got a much smaller value of y than we had for x equals negative 2. And that gives us a negative 7. So I'm going to come over here and plot that because I think we can fit it on our axis. Negative 1, negative 7. So we've got our first point. Now we know because of this value in front of the x squared is negative that our parabola is going to open down. And that's something we talked about in class. This is a reflection about the x-axis opening down. Now here's a key point. When x equals 0, that's the y-intercept of the graph, right? And I could just come up on here when x is 0, Can't I just cover up those two first terms because that's going to be 0 and that's going to be 0? And so I'm covering up all the terms with x's in them. And what am I left with? A negative 2. So when x is 0, y is a negative 2. And that's a very important value. And when a parabola or a quadratic function is in standard form, we can look out to this constant and we can say that that is the y-intercept. That's a key point for us. We know that the parabola is going to cross the y-axis at negative 2. That's a very important point because it's an easy one to get. It's the constant at the end of the equation. So y is negative 2. Now let's come on over here and let's just pick one more value. What if x were 1? Let's plug that in. I'm going to come right on down here. If x equals 1, I'm going to get y equals a negative 1 squared plus 4 times 1 minus 2. What's that going to get us? That's a negative 1 plus 4 minus 2. And that'll get us negative 1 minus 2 is a negative 3 plus 4. That gets us 1. So at 1, when x is 1, y is also 1. So I'm just going to come on over here. When x is 1, y is 1. So it looks like we're still increasing here, and we don't know where that vertex is. We really want to find that vertex. Now next week, we're going to find a pretty quick and easy way to find the vertex, but when a parabola or a quadratic is in standard form, it's not that obvious what is the vertex. So I'm just going to plug on over here and look at when x equals 2. Let me just plug that in and just make sure that we can get what's going on when x equals 2. That means y equals a negative 2 squared plus 4 times 2 minus 2. So we've got a negative 4 plus 8 minus 2. So we've got 8 minus 4 minus 2, which is 8 minus 6, which is 2. So when x is 2, y is 2. I'm just going to come right on up here. When x is 2, y is also 2. So we go 2, 2. So it's still coming up. Is that the vertex? I don't know. Let's see. Let's do one more. And I'm just going to do it right over here when x, I'm just going to come right over here just to save a little space. When x equals 3, let's pick that and see what happens. When x equals 3, y equals a negative 3 squared plus 4 times 3 minus 2. That's 9, but we've got that negative 9 plus 12 minus 2. So we've got 12 minus 9 minus 2, and that's really 12 minus 11, which is 1. So when x equals 3, y equals 1. Look what happened. We've got a trio of quadratic luck. That's what I call it. That's our trio of quadratic luck. Because look what happened. We were increasing. We got to this point, and now we're decreasing again. And now, I think we're done plugging in points because we found that vertex. Once you find that vertex, you're ready to go. So we're going to do that. We're going to finish off the parabola, and we're going to do what we did in class. I'm going to draw a vertical line, and I'm going to make it dotted. And that is your axis of symmetry. This parabola is symmetrical about the axis of symmetry, which is a vertical line that cuts right on down through the vertex. So this is our maximum value of the parabola, and this is our AOS, the axis of symmetry. And you can just label it AOS and we'll know what that is. Now, because these points are all symmetrical about this axis, we can come on over here and we can see from this axis you can go right one or left one to get this point. Well, let's come on down to this point. From the axis of symmetry, we can go 2 points left to get this point that we already plugged in using a table of values. And we can go the same distance from the axis of symmetry, 2 units, to get this next point on the other side. And we can come on down here to this lower point, and we can say, well, this point on the left of the axis of symmetry is 1, 2, 3 units from the axis of symmetry. And we can go the other direction, 1, 2, 3 units. And isn't that a nice looking parabola? I think let's try to make it a nice looking parabola. We're going to just kind of sketch up here, make it a smooth flowing curve, come down the other end. You know that it's going to continue on to negative infinity, and no matter how many points you plot for x, you will always get a y value. And it took us a few points to get that axis of symmetry and to get that vertex, but I think we got it. And that is graphing a parabola in standard form. If you need to, pause, but this is what I'll be looking for in your notes next week. Now, we often work with parabolas in standard form, y equals negative x squared plus 4x minus 2, and we can find out certain things from the parabola if it's in standard form. For example, it's really easy to find the y-intercept of a parabola that's already in standard form. But let's look at the advantages of having a parabola or a quadratic function in vertex form. Well, as we talked about in class, a parabola in vertex form, it is very easy to find the vertex. So the vertex is a really important point. From the vertex, we can find the axis of symmetry, draw that vertical line, and then reflect our points off of that axis of symmetry. But this parabola, and you remember we were doing a lot of translations from the parent function of a parabola, and if you saw this parabola in vertex form, you would know that it's opening down because there's a negative out in front of this expression with parentheses, which would eventually make that x a negative. So we know that the parabola is going to be opening down, and we know the translation from the parent function. So if I were to ask you what's the translation from the parent function, you would say, well, Mr. Fulmer, I know this goes in the opposite direction it looks like it should go, and I know this is my vertical up or down shift. Well, if I were shifting this from the parent function, isn't that going to give me my vertex? Let's see. So I'm just going to put that. I'm going to put the vertex. Now you might think, oh, the vertex is negative 1, 2. But it's not. It's close. But the vertex is, remember, we're going to change the sign of the term in the parentheses. And so I'm going to say my x-coordinate of my vertex is not negative 1, but it's a positive 1. And then I'm just going to leave this sign alone because that's a shift up from the parent function. I'm going to say my vertex is at 1, 2. Well, that's powerful information because I know that for a parabola opening down, that's my maximum value or the maximum height of the parabola. So I'm just going to plot that point because I see the vertex right there, and I'm going to go 1, 2, there's my vertex. Now I know this parabola opens down, and now I can kind of pick what's going on at the points right around that vertex because I want to know what's going on here. I'm looking for the magic 3. The magic 3. So let's verify. One thing I don't want you to do, don't try to pull the y-intercept off of here because you might say, oh, the y-intercept is the last term over here, the constant, and that's 2. Is the y-intercept at 2 at this point? No, this is not in standard form. So we can't assume that that's the y-intercept. So let's just come over here and say, what's happening when x equals 0? And see what happens. So I'm just going to plug in when x equals 0, and I'm going to plug it into my formula. Y equals negative 0 minus 1 squared plus 2. Okay, so 0 minus 1 squared is a negative 1, and I'll just write it out. A negative 1 squared plus 2. A negative 1 squared, that's the only term that's getting squared, is a positive 1. But we have to carry that negative down here, so we have a negative 1 plus 2, and that equals a positive 1. So when x equals 0, y equals positive 1. So let's just plot that point, 0, 1, 0, 1. Oh, look at that. So what would you assume when x equals 2 is going to be the next point on this side of the axis of symmetry? We haven't drawn it yet, but there's an axis of symmetry that we know exists because it goes right on down through that vertex. So let's do this. When x equals 2, let's just plug in one more point. When x equals 2, and this is really just good practice for substituting something like this. And if you do this in your calculator, you do it the same way. You say y equals negative 2 minus 1 squared plus 2. I'm going to do everything in the parentheses because PEMDAS asked us to. Minus 2 minus 1 is 1 squared plus 2. That's a negative 1. Move on up here. That's a negative 1 plus 2, which also equals 1. So as you would guess, because this parabola is coming on up here, and we move over to here, when x is 2, y equals 1. So we're going to come up here, 2, 1, and now the parabola is coming back down. And you know what I'm going to do? I'm going to pick one more point. And the reason I'm going to do that is because I want to see where this parabola is going. But first I'm going to draw my axis of symmetry right on down through that vertex. And I'm going to call that the AOS, axis of symmetry. In fact, the axis of symmetry really doesn't need arrows. It's just an axis. So it continues, but let's just keep it like that. That's our axis of symmetry. And you can see that these two points are reflected across the axis of symmetry. Now, wouldn't it be nice to get one more point so that we can finish off what happens when we come on down here beyond this value of x? What would happen if we would plug in, oh, say, x equals 1, 2, 3? Won't that give us a nice point to finish off this side of the parabola? Let's do that. I'm just going to work over here because I already know my parabola is coming down here somewhere. So I'm just going to say, what happens when x equals 3? And let's just practice by plugging in those values. Y equals negative 3 minus 1 squared plus 2. I'm going to let you work it out, and then you tell me what happens when x equals 3. What happens? Let's see. 3 minus 1 is 2 squared. If there's a negative, is 2, which is a negative 3 plus 2, which is a negative. Did you get negative 2? When y, or when x is 1, 2, 3, y is 1, 2, negative 2. Look how nice that parabola is starting to shape up. Now, that's about it. That's all we need for points, because once we've got this point at 1, 2, 3, negative 2, here's the axis of symmetry. That point is 2 units away from the axis of symmetry to the right. And so to get this next point, it's 2 units away from the axis of symmetry. And that looks pretty good. We can start to plot that parabola. It goes to negative infinity in the y direction. And that looks like a pretty good parabola. And really all we needed to do was pick a couple of points once we got that vertex. We got that vertex using these numbers right there. Isn't that fun? Well, the better you get at it, the more fun it will become. So why don't you try a couple of them on your own, and we'll just do 2, and bring them to class and we'll check them when you get here next week. Let's try one in standard form and one in vertex form. So the ones I'd like you to graph on your own by really plugging in some points and finding that vertex, and then finishing it off using the axis of symmetry, we're going to do y equals negative x squared minus 2x plus 1. Try that one on your own. That's in standard form. And then we'll put one in vertex form. See if you can do that one by finding that vertex right away. And that would be negative x plus 1 squared minus 3. Plug in some numbers, get that axis of symmetry, find those 3 special points, and we'll see you next week. Thanks for watching.